two identical resistors, each of 12 ohm, are connected in series and case B in parallel. In turn to a battery of 6 volt. Calculate the ratio of power consumed in the combination of the resistors in the two cases. So basically, let me show what they're asking you guys to figure out. First thing first, let me draw a circuit diagram. So first thing is your series connected to a battery of 6 volt. This is 12 ohm and this is 12 ohm. Next we have another circuit with parallel connection. And this too is 6 volt. And we have 12 ohm and 12 ohm. Right? So they're asking what is the power consumed by both the circuit. It depends on the voltage and the resistance, right? We can calculate that way also. So voltage is fixed, right? Somehow we have to figure out. Okay, not somehow, you guys know how to figure out the effective resistance. So thus we'll be able to find the power ratio of the power actually. So how do you do this? First thing first, let's write the given. Given is already written actually from the diagram. Let's find the effective resistance in series connection. So Rs is equal to R1 plus R2. So which is nothing but 12 plus 12. Which is nothing but 24 ohm. So this is your resistance in series. Right? Then what is the power? Power is quite simple. V squared by R. Is it not? So this is 6 squared by 24. Let it be. This is in series power. Power consumed in series. So next is power resistance in parallel. So this is 1 by Rp is equal to 1 by R1 plus 1 by R2. So this in turn is equal to 1 by 12 plus 1 by 12, which is 2 by 12, 1 by 6. You need not write so many steps. You can just directly write Rp is equal to 6 ohm. Okay. These steps can be skipped actually. This too. Now, power consumed in parallel. So that will be equal to V squared by R, which is 6 squared by 6. So they want the ratios. So ratios will be simple. Power consumed by series connection and parallel connection is equal to series is 6 squared by 24. Parallel connection is 6 squared by 6. So we have this to be 6 squared by 24 into 6 by 6 squared. So this and this will get cancelled and we have 1 by 4. Right? So in parallel connection. So remember, I'm just cross multiplying. So parallel connection is equal to 4 times of series connection power consumption. So what can you conclude? In parallel, we have more power consumption than in series. It should be obvious because the current drawn over here will be much more than the current drawn over here. Again, the answer should be obvious because the effective resistance over here reduces while here it increases. Right? So if you look at it, it's not that technically it's not that hard. It should make sense. Okay, it should make sense to you guys because it's not something which is new to you guys. Effective resistance over here decreases, here it increases. Here the current will be by default more. Here the current will be less. Is it not? Right? So since the current is less, the power consumption will be less. And it's just 1/4 of parallel connection. So advantages parallel has a lot. But the one thing is you need to understand is there will be more power consumption. Remember, energy cannot be created nor destroyed. So here the energy consumption in parallel is more. I hope that makes sense. So this is a good question. In many aspects, it covers a lot of concepts actually. Okay, anyways, please pause and note it down.